Hello friends, hope all are good today. Welcome to my channel Chem Solution. So today we will discuss the most important part of thermodynamics, that is heat capacity and the relation between Cp and Cv. What the relation gives us: first of all, heat capacity, molar capacity and specific heat capacity. Okay, so let's start with it. I hope you will subscribe my channel as you like the content. Let's begin. First of all, what is heat capacity? You can say that if we have any substance and we have to increase this temperature by 1 degree, okay, that heat required is known as heat capacity. The amount of heat a substance can be a substance needed to change this temperature by 1 degree. Okay, so heat capacity in general, the ability of material to absorb the heat, and quantity, we can say the energy required to increase the temperature of the material to 1 degree. Okay, 1 degree. You can say this is the heat capacity. dq upon dt will be the formula. Energy input, what energy we are involving in it, that is joule per mole, and below that temperature change is there in Kelvin. Then the unit of heat capacity will be joule per mole Kelvin. Okay, so we can say that it is just the heat that required to change the temperature of substance. Okay, if there is a 1 gram of substance, that will be the specific heat. You can write C is equal to thermal energy upon change in temperature. Clear? This is heat capacity. Next one, this have two types of heat capacity are there, Cp and Cv. So heat capacity at constant pressure and heat capacity at constant volume, both are important terms, so you have to remember this. Next is the molar heat capacity. We have to just take 1 mole of substance here, nothing else, 1 mole of substance, and the temperature will be in centigrade. So the molar heat capacity is the amount of heat required to raise the temperature of 1 mole of substance. 1 mole of substance by 1 unit is calculated by dividing heat capacity by the total number of moles. You can see here, this is the specific heat capacity taken, and this will be the molar heat capacity, because moles are there, their temperature in Kelvin, and there here 1 degree Celsius. Okay, this is the molar heat capacity. Next, the most important part is Mayer's formula, derivation of Cp minus Cv is equal to R. Pv, what we will take here, first of all, we have to take the ideal gas for it. So for ideal gas, we will, if ideal gas is there, ideal gas, what is the formula of ideal gas? Pv is equal to nRT. Okay, this will be the formula for ideal gas. This is number of moles, n is equal to number of moles, n is equal to number of moles. If here 1 mole is taken, and what the reaction will be? Pv is equal to nRT will be the reaction. Okay, this will be the reaction. Now we have to take some system having the temperature T1 at V1 volume, and other system which have temperature T2 at T2 volume. Okay, so what the reaction will make now? P V1 is equal to R T1. Here we will not write n because it is the only taken as 1. Okay, so it will be first equation, and second one will be like this: P V2 is equal to R T2. This will be the second equation. Now you have to subtract 2 minus 1, and what will we get here? We have to take the common in both the cases. Okay, so I am writing here P V2 minus P V1. The most like particles are on the left side, and the other one are on the right side, RT2 minus RT1. Here take P as the common, and V2 minus V1 it will be is equal to, take R is here common, then it will be T2 minus T1. Clear? So next we have to do what we have to do. I have to write the reaction again, that P V2 minus V1 is equal to R R2 minus, it will be T2 minus T1. T2 minus T1. So what is this? This is change initial minus final minus initial. So P delta V it will be there. Okay, this is also final minus initial. R delta T will be there. This equation you name that third equation. Now we know that enthalpy, equation of enthalpy is internal energy plus external pressure and volume. This will be the enthalpy equation we have learned previously. So put this, you have to take the change here, delta U plus P delta V. Okay, now put this P delta V, this equation 3, P delta V, in this, and what will be the equation? Delta H is equal to delta U plus RT. Okay, so this will be the reaction. Now what I have to do? You have to divide this T by the whole equation. Delta H is equal to delta T is equal to delta U upon delta T plus R. Here, now what is delta H upon delta T? Delta H upon delta T is Cp, and this will be internal energy upon delta T is Cv. Okay, so what will we make here? Is equal to plus R. Take the Cv there, left hand side, then the equation will be Cp minus Cv is equal to R. This is the equation, this is the relation between Cp and Cv. Specific heat at constant pressure and specific heat at constant volume. So I hope you like my video. Please like and subscribe. Thank you.